Well, hello again, ladies and gentlemen. We are on our last lesson for college algebra. I can hardly believe it that this is it. We are going to be looking at the identity matrix and inverse matrices. And ultimately, we are on a very abbreviated version of the inverse matrices. So just kind of follow along. They did cut a lot of that out for us due to kind of the situation that is going on. But from this, what we do need to make sure we know is what is an identity matrix. An identity matrix is a square matrix that has ones all along the main diagonal and zeros above and below for our other elements. It looks a lot like when we were solving matrices using that RREF, that we had that diagonal of ones, and then with that we had those zeros above and zeros below. So this happens to be the identity matrix of a 2 by 2 because that is the size. 2 rows, 2 columns, ones along the diagonal, zeros above, zeros below. This is the identity of a 3 by 3. So we have that diagonal of ones. And once again, we're going to have zeros above and zeros below. So if we were asked, for example, to write the identity matrix of a 4 by 4, that 4 by 4 simply means what is the size, and that letter I stands for identity. So we know it has 4 rows, 4 columns, so we're going to have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then finally 0, 0, 0, 1. And then looking at, we have our main diagonal of ones with our zeros above and then our zeros below. So for example, if we're going to multiply a matrix by that identity, ultimately it is the same thing as multiplying by 1. So if we went, what is 4 times 1? You guys would all know, hey, that's equal to 4. Well, that identity matrix serves as the same purpose. So right now, here's our matrix. Here's our identity. And we want to find what is the product. So we're going to go ahead and grab our handy dandy calculators. And we're going to go ahead and do alpha zoom. Remember, our size is rows by columns. This is a 2 by 2. So then that would be 2, 5, 1, 3. And we want to multiply that by the identity. So alpha zoom, also a 2 by 2. So that's 1, 0, 0, 1. And ultimately with that, the product of that should be our original matrix. And oh my gosh, lo and behold, it is. So this equals 2, 2, 5, 1, and 3. So when we're multiplying that matrix by the identity, we get the original matrix. So when we multiply a matrix by the identity, we get the original matrix. And remember that identity is the same thing as multiplying by 1. So see, if we wanted to identify the product of A times I, this is saying, hey, this is just a matrix. This is the identity. And that means, hey, that product is going to be just A. We also mentioned in our last lesson that matrix multiplication is not commutative, correct? However, when we are multiplying by that identity, it happens to be the only time when it is true. So we know that A times I equals A, and also I times A equals, in this case, A. This is the only time matrix multiplication can possibly be commutative. Otherwise, it is 100% not, that the order does matter. Then our last little thing that we are just going to touch on super briefly is inverse matrices. And that is that two matrices are going to be inverses of each other when their product is the identity. And what that is saying, if we recall, with kind of our multiplication rules, if we went 4 times 1/4, because these are inverses of each other, their product is 1. So if we went 3 times 1/3, that product is also 1. If we went 2/5 times 5/2, that is going to be 10/10, which is still 1. So that would be that if we have our matrix, this is the inverse of the matrix, and then their product is the identity. So if the product of two matrices is the identity, then they are inverses of each other. So if the product of two matrices is the identity, then they are inverses of each other. And then the last little thing is we want to show that B is the inverse of A. So all we're going to do is take our calculator and find out what their product is. And in order to show that, we're hoping that the product we want the product to be the identity. So we want that diagonal of ones, zeros above, and zeros below. So we're just going to put this in our calculator. -1, 2, -1, 1. And we're going to multiply that by 1, -2, 1, -1. So I'm going to go ahead and grab that. Notice once again alpha zoom, 2 by 2. And so that would be -1, 2, -1, 1. And we're going to multiply that by our next matrix, alpha zoom. And that is also a 2 by 2. 1, -2, 1, and -1. And we are now going to go ahead and press enter. And notice that, hey, our answer is 1, 0, 0, 1, diagonal of ones, and we have our zeros above and zeros below. So these two matrices are inverses of each other. Oops. So these two matrices are inverses of each other. And that is it, ladies and gentlemen. So I miss you very much, and I will hopefully see you guys all very soon in a Zoom meeting. But yay, we have actually survived and made it to our last Unit 5 lesson. I will hopefully see you guys soon. Good night.